Hello friends, in this video we will discuss basic logic gates. Basic logic gates are basically the units we are using in digital electronics, basic devices we are using in digital electronics. So in this video we will discuss three gates: AND, OR and NOT. For other logic gates like XOR gate, NAND gate, NOR gate and different applications of these gates, you have to see my other videos. So in this case we will start with AND gate. So if we see the device symbol, AND gate symbol, then this is the symbol of AND gate, right? Where we two input AND gates and this is the output, say C, right? These are the inputs. So this is the symbol of AND gate. We can have any number of inputs, I mean 2 raised to the power 2, 2 raised to the power 1. So these are the 2 input AND gates, then 4 input AND gates, and that way we can use. So once we are starting with AND gate, 2 input AND gate, so just to see the behavior of the device, we'll refer a table which is called the truth table. So truth table is a table which defines the relation between inputs and outputs. Since we are having 2 inputs only and we know the binary systems is working on 2 raised to the power n, so in the case of 2 inputs, the maximum variation of inputs are 4. And in cyclic order, this is the order. This is the maximum possibility of variation of inputs if we are having 2 number of inputs. So if you see the AND gate, once both the inputs are 0, then we are getting 0 at the output. Once first input is 0, second input is 1, we are getting 0 at the output. Once first input is 1, second input is 0, again we are getting 0. Once both the inputs are 1, we are getting 1 at the output. C. The only possibility once we are getting 1 at output or high at output once both the inputs are 1. This table, once we study this table, truth table, then we can understand how this device behaves. But for applications, we have to analyze the same truth table in a different ways depending on the problems we are solving. For example, if I want to analyze this table in a different way, then I can divide this table in 2 parts and I am concentrating on input A, right? So once both the times in both the states, once input A is 0, second input is 0, we are getting 0. Once A is 0, second input is 1, again we are getting 0. So how I am analyzing is, once my input A is 0, it doesn't matter what is the value of B, we are getting 0 at the output, right? This is a way of analyzing. Second thing is, once the input, my input is 1, 0, then we are getting 0. 1, 1, we are getting 1. So I am analyzing this in a way, once my input A is fixed on 1, then second input will be available at the output. See, 0 is here, 0 is here, 1 is here, 1 here. So this way we can analyze the logic gates and use it in different applications, right? Now, the second gate we would like to discuss in this video is OR gate. So symbol of OR gate is like this. So A, B are the two inputs and this is the output, say C. Here what you have to take care is this shape. This is curvature shape, this is straight. So once you are representing gate in a symbol, that symbol should be exactly same. So here something curvature type of things, right? Now if we see the truth table, again it is a case of two inputs, right? A and B and C is the output. So similar way with the binary combinations, since we are having two inputs, the maximum possibility of variation of inputs are 4. 1, 2, 3, 4. So in the case of OR gate, once we apply 0 on both the inputs, then we are getting 0 here, right? Once first input is 0, second input is 1, we are getting 1 here. One input is 0, second input, first input is 1, second input is 0, again we are getting 1. 1, 1, again we are getting 1, right? See the difference between AND and OR. And since if you analyze these three states, then we can say if we are having at least one input 1, we are getting 1 at the output, right? This is why we say OR gate is somewhat flexible as compared to AND gate. So why I am saying this? Because whenever we want to apply strict conditions, we use AND gate. And once we want comparatively flexible conditions, then we can use OR gates. Okay? The third gate is NOT gate. Okay? This is basically just to generate the complement. I am sure you are familiar with this. This is known as buffer type of device. So if we use invert option in this, then this is called NOT gate. So what is the function of this? Whenever we apply something on the input, just it generates the complement at the output. So once I am applying 0, once I am applying 1, I am getting 0 here. Once I am applying 0 at the input, I am getting 1. So if, as you know the Boolean algebra, so this complement generation is very, very important. So that way this NOT gate is very, very useful in the case of designing and development of complement combinational circuits. For this video, thank you very much. For any query, use my WhatsApp. I am also available in email for discussions and for your queries. Thank you for watching this video.